In Unit 2, Learning Set 6, we're going to learn about continuous compounding interest. Um, this is when you compute interest on an account that is compounded continuously. So before we start on the formula, think about how can interest be compounded continuously? So ask yourself, can interest be compounded daily? Yes, we know from previously that that would be 365 days a year. So every day you would compound your interest. Well, what about hourly? Is that a set time frame? Well, yes. If we take 365 times 24 hours a day, that will give us a compounding amount of 8,760 hours. What about each minute? Yeah, you can do it each minute. 365 days times 24 hours times 60 minutes for each hour. That would give us 525,600 minutes. So what about every second? Yeah, you can do it every second. Same thing. That's 365 days a year times 24 hours a day times 60 minutes an hour times 60 seconds every hour. That would be compounding 31,536,000 seconds. And that would be a lot. And time just keeps getting smaller and smaller and smaller. And one thing you will find is as time gets smaller, it gets closer and closer and closer to a single value. So in continuous compound, we're going to use an exponential base. And by definition, an exponential base is represented by e, and it is an irrational number, which is a non-terminating, non-repeating decimal with an approximate value of 2.718281828, and it just keeps going on and on and on. And this is similar to pi. If you remember, pi is never ends. It's always got different values. So on a calculator, you have this e to represent the exponential base, just like you have the pi symbol on a calculator. And if you look on a graphing calculator, there is an e to the x, and it's right above the ln button. Ln is natural logarithms that you can access using the second function. So if you're thinking on a calculator, you would have a button with ln, and right above it would have e to the x. So you would have to hit the second button to use the e to the x. Now the value for e, this irrational non-terminating number, is already programmed in there with the e. So what will show in your calculator is the e, and then it'll prompt you to put in an exponential amount. So the continuous compound interest formula is B equals P times e to the RT. And we know B is our ending balance, P is our principal or original balance, E is our exponential base, R is our rate expressed as a decimal, and T is time. So the only real new variable in here that you haven't been introduced to is E for the exponential base. And that is not even something that you have to derive out of the information given to you. So let's look at this example. If you deposit $1,000, that's our principal amount at a 4.3% interest, that's our rate. Now this is where you have to focus in. It's compounded, but they are saying continuously. That word continuously with compounded tells us that we need to use the continuous compounded formula. what would your ending balance be to the nearest percent after 5 years? So that's our time frame. So we get our variable. We're looking for our balance. So we don't know what our B is. Our principal is 1,000. Our rate converted is 0.043, and our time is 5 years. So we take our formula of B equals PE to the RT, plug in our values, and then in your calculator, you're simply going to type in 1,000 times and then select that exponential base variable E, and then in the exponent position, multiply the 0.043 times 5, and you end up with 1,239.861897. Now, in here, it says you want to go to the nearest cent. So nearest cent means we're going to the second decimal place. So in this case, 6 is followed by 1, so we don't round anything, and our ending balance after 5 years of compounding continuously is $1,239.86. So let's try another one. Craig wants to deposit $5,000 at a 5.12% interest rate, compound it continuously for 4 years. What would his ending balance be to the nearest cent? So once again, continuously. So we have to use our B equals PE to the RT formula. Let's list out our variables. We don't know what our balance is. That's what we want to find. We know our principal is 5,000, our rate is 0.0512, and our time is 4 years. Plug it in, put it in our calculator, and solve it, and then nearest cent. Remember, nearest cent means we're looking at this 9. So when we look at this 9, the 7 says round up. Well, what's above 9? It's 10. So that means this 9 is going to become 10, which makes the 3 go to 4. So our ending balance is going to be $6,136.40.